students. Welcome to the 20th session of Quantitative Decision Tools. In this session, we shall understand the calculation of standard deviation under discrete series or grouped data non-continuous. The structure of the session would be starting from learning objectives followed by session outcomes, calculation of standard deviation, summary and references. The objective of the session is to understand the calculation of standard deviation under discrete series. So the outcome would be the student shall be able to understand the calculation of standard deviation. So again, in this calculation we have various forms of data, that is ungrouped data, discrete series and grouped data continuous. Ungrouped data is discussed in session 19. Grouped data is discussed in session 21, that is grouped data continuous. In this session it is specifically for grouped data non-continuous, that is discrete series. So under discrete series there are two methods. One is based on deviations taken from actual mean and assumed mean. So let us understand this illustration. Calculate standard deviation where they have given marks and number of students. Marks will be considered as x and number of students as f. Now I'll first calculate fx, that is I multiply frequency with the observation, that is x. After fx, that is why fx is calculated is for the calculation of mean. Mean is equal to sigma fx by n. Now I calculate deviations. Deviation is equal to x minus x bar. X bar as already calculated, it is 30.8. So the first deviation will be 10 minus 30.8, that is minus 20.8. Similarly, I calculate deviation for all the observations. Next, I square these deviations, and finally I multiply these squared deviations with the frequencies to take the summation of fd square. Then I'll apply the formula. Standard deviation is equal to whole root of sigma fd square divided by n. Sigma fd square, it is 10,858.40 divided by n is the total of frequency 60. So I get root of 180.97, that is 13.45. Coming to the assumed mean method, here I don't calculate mean. Instead I assume any one of the value as mean. So out of the given observations, I have assumed 30 as assumed mean. Next I calculate deviations. D is equal to x minus a. So 10 minus 30, I get minus 20, and similarly I calculate d. Next I square these deviations to get d square. Next I multiply frequency and deviations, that is fd. And finally I multiply frequency with squared deviations, that is fd square. I'll apply the formula. Standard deviation is equal to whole root of sigma fd square divided by n minus sigma fd by n whole square. Sigma fd square is 10,900 divided by n is 60 minus sigma fd is 50 divided by n is 60 whole square. If I simplify, I'll get standard deviation as same here also, that is 13.45. If I like to summarize, standard deviation under discrete series can be calculated from assumed mean or actual mean. Also, you can calculate the standard deviations. These are the references that I have used for this session. Thank you.